All right, welcome to Talk Tensors. We're going to be diving deep into the world of machine learning today. As always, we're taking those complex research papers and breaking them down for you.
Exactly. So whether you're knee-deep in the field or just curious about AI, we do the heavy lifting, bringing you the most interesting findings and what they actually mean.
And today, we've got a really fascinating paper. It's a survey paper, actually, all about long chain of thought reasoning. It's often called Long CoT.
Now, if you've been following the latest in large language models, or LLMs, you've probably heard of chain of thought prompting, right? Where these models break down complex problems into smaller steps.
Right, they kind of think out loud to figure things out.
Exactly. Well, Long CoT, it takes that basic idea and ramps it up, like significantly. It's getting a lot of attention because it's really pushing the limits of what AI reasoning can do. And this paper, being a survey, it's a great way to get the big picture of where the research is at right now.
So today, we're going to unpack the paper for you. What is Long CoT? How is it different from the earlier stuff? What are some of the crazy discoveries researchers have made with it? And where might it be headed in the future?
Right. And our mission, as always, to extract the golden nuggets from this paper, give you those aha moments. We want you to walk away with a solid understanding, but without feeling overwhelmed.
Absolutely. Okay, so let's dive in. This survey paper, it paints a pretty comprehensive picture of the current state of Long CoT research, right?
Yeah, it does a great job of laying things out. So it starts by making a very clear distinction between Long CoT and the earlier, shorter forms of chain of thought reasoning, the ones that came before. And then it digs into what makes Long CoT unique.
Right, so it goes beyond just defining it. It really explores those defining characteristics, right?
Yeah, and then it goes even deeper, like it tries to get at those underlying mechanisms that researchers think are at work. What's actually happening inside these models that allows Long CoT to do its thing.
And then, of course, it's always exciting to talk about the future, right? So I'm guessing the paper also explores some of the potential future directions for Long CoT.
Oh, absolutely. And it's important to note that this paper is kind of a big deal because it claims to be the first dedicated survey specifically focused on the nitty-gritty of Long CoT.
So this is kind of like the definitive guide, at least for now.
Right. It really highlights how important and how fast-moving this particular area of machine learning has become. And the authors, they make a really strong point about Long CoT being a crucial technique for improving the accuracy of robust large language models, or RLLMs as they call them.
RLLMs.
Yeah. So it's not just about getting the right answer in the end, but also about making the entire reasoning process more robust, less prone to errors. And that's what Long CoT seems to be doing. It's also enabling these models to tackle more complex and dynamic situations to make more sophisticated decisions.
Yeah, okay. So it's clear Long CoT is a big step forward. But to really appreciate how we got here, maybe we should go back in time a bit, right? What led to its development?
Right. So the paper takes us on this journey, a fascinating evolution from what they call short CoT to the more advanced Long CoT.
From short thoughts to long thoughts? Makes sense.
Yeah, but it wasn't like this sudden breakthrough. It was a gradual process, a merging of different research efforts that were initially kind of separate, like different teams working on different pieces of the puzzle.
Interesting. So it was more like a convergence of ideas.
Exactly. And what's cool is that the things that define Long CoT today, those core elements like deep reasoning, the ability to think deeply and logically, then there's extensive exploration, the ability to explore lots of different possibilities, and then feasible reflection, the ability to look back and critique your own thinking. These are often being studied in isolation.
So each of those capabilities was being developed on its own track, so to speak.
Right. And then at some point, they all started to come together. And the paper lays out this progression really well. So first, within the traditional chain of thought framework, the focus was on enabling deeper levels of reasoning.
Okay, so they wanted the models to think more deeply.
Yeah, to go beyond just a few steps of logic. And then there was a growing interest in incorporating reflection. But early on, these reflection mechanisms often required a lot of human intervention. Like humans would have to design the feedback loops or guide the model's self-correction.
So the models weren't really reflecting on their own yet.
Not fully. They needed more hand-holding. And then came the advancements in exploration. Models started to get better at considering multiple paths, not just the most obvious one, and they could explore a wider range of possible solutions.
So they became less rigid in their thinking, more open to different options.
Yeah, exactly.
Yeah.
And the survey paper argues that what we call Long CoT today, it's really a unification of these three things. Deep reasoning, extensive exploration, and feasible reflection, all working together, in sync.
So it's like the ultimate upgrade to chain of thought.
Right. It's like they took the best of each of those capabilities and combined them to create something even more powerful. And the paper, it even has this figure too that visually shows this whole evolution. It's a timeline of how these different pieces came together to form what we now know as Long CoT.
Okay, I wish we could show it to our listeners, but alas, we're audio only.
Right, but even just hearing about it, you can get a sense of how it captures that historical progression of ideas.
All right, so we've got a good feel for the historical context. Now let's get into the specifics. What exactly makes Long CoT stand out? What are those defining characteristics that set it apart, according to the paper?
So they highlight three key features. First one, it's deep reasoning. And this isn't just about taking a few logical steps, right? It's about the model's capacity for handling a really deep, intricate network of reasoning steps.
Like being able to keep track of a long and winding train of thought.
Exactly. Think of it like navigating a complex maze. The model needs to be able to hold a lot of information in its mind at once and make connections between all those different pieces.
So it's about managing that complexity.
Right. And the second key characteristic, it's extensive exploration. This goes beyond just following a single path, a single line of logic. It's about the model being able to generate multiple paths, multiple hypotheses, even if some of them seem a bit uncertain at first.
So it's almost like brainstorming, trying out different approaches and seeing where they lead.
Exactly. And this is important because it allows the model to consider solutions that might not be immediately obvious. Those out-of-the-box ideas.
And then the third characteristic you mentioned earlier, it's feasible reflection, right?
Right. This is where the model gets to be a bit self-critical. It can look back on its own thinking, evaluate its steps, identify any potential errors or weaknesses.
So it's like it has a built-in quality control mechanism.
Yeah, exactly. It's constantly checking its work, refining its logic, and making sure it's on the right track. And the paper makes a really strong argument that it's the combination of these three things, deep reasoning, extensive exploration, and feasible reflection, that allows Long CoT to handle much more complex tasks than previous methods.
Like it's the trifecta of advanced AI reasoning.
You could say that. It allows these models to be more accurate, more efficient, and their reasoning, it just makes more sense overall. It's more coherent.
Now, the paper also spends a good chunk of time talking about some of the interesting phenomena that researchers are observing with Long CoT. And one of the first ones they discuss is the Long CoT emergence phenomenon. What's that all about?
So the Long CoT emergence phenomenon, it's this really intriguing finding. Basically, when you show large language models examples of detailed step-by-step reasoning, they get much better at generating their own reasoning chains for new problems.
So they're learning by example, kind of like an apprentice watching a master craftsman.
Yeah, it's like they're picking up the tricks of the trade. And what's even cool is that researchers have tried stripping those examples down to just the bare bones logic, removing all the specific details about the problem.
So just keeping the structure of the reasoning process.
Exactly. And surprisingly, even with these super simplified examples, the models still show improvement, which suggests that Long CoT is about more than just mimicking specific solutions. It's like they're learning the shape of reasoning itself, the abstract principles behind it.
That's wild. It's like they're figuring out how to think logically on a deeper level.
Right. And the paper also points out this really interesting difference between models. Some, like Quen, they seem to have some inherent Long CoT abilities already baked in, and you can kind of nudge them along with rule-based reinforcement.
Rule-based reinforcement, is that like giving them rewards for following the rules of good reasoning?
Exactly. But other models, like Llama, they seem to need a bit more hand-holding. They benefit more from example-based learning, where you actually train them on a ton of examples of successful reasoning chains.
So it's like some models are natural-born logicians, while others need more coaching.
Yeah, that's a good way to put it. It really shows that the design of these models and how they're trained can have a big impact on their ability to do Long CoT.
Now, another phenomenon the paper delves into is the reasoning boundary phenomenon. This sounds like it has to do with the limits of these models' reasoning abilities, right?
Yeah, it is. So it's kind of a reality check. The reasoning boundary phenomenon, it highlights that even the most powerful LLMs, they have their limits.
So no matter how big or sophisticated they get, there are some things they just can't reason through.
That's the idea. And it's especially true when you start dealing with really complex problems or when the reasoning chains get super long.
So it's like a computational cliff they fall off of if the problem gets too hard.
You could think of it that way. They call it a reasoning boundary. Yeah. And if you push a model past that boundary, its performance actually starts to drop. But here's the catch. Within those boundaries, giving the model more reasoning steps can actually help it solve harder problems. It's like breaking the problem down into smaller, more manageable chunks.
So more steps can be good, but only up to a point.
Right. And the paper also briefly mentions this idea of a tight lower bound. Basically, it's like the minimum amount of reasoning a model needs to avoid making certain kinds of mistakes. And they give this really interesting example of multi-digit addition, adding up a bunch of numbers.
Okay, what about it?
So it turns out that many models, they rely on this single-digit look-ahead strategy when they do addition, which means they can only really handle a limited number of digits at once. So if you give them a super long addition problem, they're likely to mess up because they can't see far enough ahead.
That's a great illustration of a very specific limitation.
Yeah, it really shows that there are these fundamental constraints on their reasoning abilities. And speaking of limitations, let's talk about the overthinking phenomenon.
Overthinking. Can a language model think too much?
Apparently they can. So the overthinking phenomenon, it's this observation that sometimes when a model's reasoning process gets too long or too complex, it actually starts to perform worse.
You'd think that more thinking would always be better, but...
Yeah, you'd think so.
Yeah.
But it seems like there's a sweet spot. If they overthink it, they might get bogged down in details, make more mistakes, or even lose sight of the main goal.
It's like they're going down a rabbit hole of their own thoughts.
Exactly. And there's research going on right now to try to figure out mathematically what the optimal length and complexity of reasoning is for different tasks.
That sounds really complicated.
It is. And the paper even mentions something called Faraday's law of Long CoT. Don't ask me to explain it in detail, but it's basically a principle that tries to predict and control the performance of Long CoT based on the length and complexity of the reasoning.
Faraday's law of Long CoT. Catchy name.
Right. It makes you think there might be these fundamental laws governing how these models think, just like there are laws of physics.
Very interesting. Okay, so we've talked about boundaries and overthinking. What about the inference test time scaling phenomenon? What happens when you give the model more time to think during testing?
So this is all about playing with resources. Inference test time scaling. It looks at what happens when you give a model more processing power or more time to reason during the evaluation phase. Like, do they get better at solving problems if you let them think longer?
So it's like giving them extra time on a test to see if they can come up with better answers.
Exactly. And there are two main ways to do this. The first is vertical scaling, where you let the model generate a longer, more elaborate chain of reasoning within a single attempt. Like giving them more space on the page to write out their solution.
So deeper thinking, but in one go.
Right. And while this can lead to improvements at first, the paper points out that there's a limit to how much it helps. Beyond a certain point, the performance actually starts to decline, probably because longer chains are more prone to errors.
Each step is a potential point of failure, so the more steps you add, the more chances there are for things to go wrong.
Precisely. And the second approach is parallel scaling, where you have the model explore multiple reasoning paths at the same time. Like, instead of just following one line of thought, it's branching out and exploring several possibilities in parallel.
So more like a team of thinkers working on the problem from different angles.
Yeah, that's a good analogy. And while this seems like a good way to avoid getting stuck on a single wrong path, the research suggests that just throwing more computing power at it doesn't guarantee better results.
So it's not a magic bullet.
Nope. There still seem to be these inherent limits to how well a model can reason, no matter how much time or resources you give it.
Makes sense. You can't force intelligence. Okay, so the last phenomenon the paper discusses is the knowledge incorporating mechanism. How do these models use all the information they have stored in their digital brains to reason through problems using Long CoT?
So this is a huge area of research. We know that these RLLMs, they have a ton of knowledge. They've been trained on massive data sets, right? But the question is, how do they access and use that knowledge effectively during Long CoT reasoning?
It's one thing to have a library full of books. It's another to actually find the information you need and use it to solve a problem.
Right. And one of the leading ideas is that these models, they store their knowledge in a kind of modular way. Like, All those facts and entities, they're stored in separate compartments, and Long CoT helps them connect those pieces together in a meaningful way.
So Long CoT acts like a bridge between those isolated bits of information.
Exactly. And to better understand how this works, researchers use something called the probabilistic mixture model. It's a way to analyze a model's output and figure out how much of it came from actual reasoning, how much was just memorization, and how much was basically guessing.
So it's like a detective work trying to understand the model's thought process.
Exactly. And then there's this concept of concept depth. It refers to the fact that different types of knowledge seem to be stored at different levels within the model's neural network. Like some things are easier to access than others.
So the more abstract or complex a concept is, the deeper you have to go to find it.
That's the idea. And then there's also this fascinating idea of knowledge loop evolution. It suggests that the way a model learns new knowledge is shaped by the knowledge it already has. So it's a kind of self-reinforcing cycle.
So the more they know, the easier it is for them to learn even more.
Exactly. It's a pretty amazing phenomenon.
It is. Now let's wrap things up by talking about the future. The paper outlines several promising research directions, what it calls novel notions. And we wanted to focus on one in particular, multimodal long CoT. Why is this so exciting?
Well, multimodal means going beyond just text, right? It means incorporating other types of data, like images, videos, audio, even code.
So instead of just reading text, these models could be looking at pictures, listening to sounds, that kind of thing.
Exactly. And this opens up a whole new world of possibilities. For example, imagine a model that can analyze a medical image, listen to a doctor's spoken diagnosis, and then use all that information to reason about the patient's condition.
That would be a huge leap forward in medical AI.
Absolutely. But there are some big challenges too, like how do you get these different types of data to talk to each other within the reasoning process? How do you make sure they're all contributing to the final solution?
Yeah, integrating all that information seamlessly can't be easy.
Right. And then there's the issue of scaling up those longer reasoning chains to work with multimodal data. It's going to require some clever techniques and algorithms. But if researchers can crack the code, multimodal long CoT has the potential to revolutionize how AI interacts with the world.
Definitely a space to watch. And the paper also mentions a few other future directions, right?
Yeah, it touches on things like multilingual long CoT, where models can reason in different languages. Then there's agentic long CoT, where models are embodied in agents that can actually interact with the physical world. And efficient long CoT, which is all about making those long reasoning chains more computationally feasible.
It sounds like there's a lot of fertile ground for future research.
Oh, absolutely. The field is just exploding with new ideas and possibilities. And one more important area they mention is safety.
Safety. Why is that a concern with long CoT?
Well, as these models get more powerful and their reasoning chains get longer, there's a risk that they could generate outputs that are harmful, biased, or just plain wrong.
So it's not just about making them smart, it's about making sure they're responsible too.
Exactly. It's like with any powerful technology, we need to make sure we're using it for good and that we're mitigating the potential risks.
Right. Well, it sounds like the world of long CoT is a fascinating and rapidly evolving one.
It is. And it's going to be exciting to see where it goes from here.
Well, that brings us to the end of our deep dive into long chain of thought reasoning. We've covered a lot of ground today, from the basics to some pretty mind-bending concepts.
Hopefully our listeners have a better understanding of this amazing field now.
Yeah, and we've given them plenty to think about too. So, as a final thought, given all these incredible advances and the potential limitations of long CoT, what do you think are the most promising paths forward? How can we truly break through those reasoning boundaries and solve the really big problems that humanity is facing? Or maybe, think about this, how might multimodal reasoning fundamentally change the way we interact with AI and how AI interacts with us?
That's a great question. It's something we all need to be thinking about as these technologies continue to develop.
Absolutely. And if you want to learn more, we encourage you to check out the paper itself and explore some of the other resources we mentioned.
Yeah, there's so much exciting research happening in this area, and we're just scratching the surface.
All right, well, that's all the time we have for today. Thanks for joining us on Talk Tensors, and we'll see you next time for another exciting deep dive into the world of machine learning.
See you then.